Okay, so today, ya, ada orang cakap tadi. Ke saya tak dengar? Okay, dengar semua?
Dengar.
Dengar ya?
Dengar,
Okay.
dengar.
Alright, so saya continue we right now is 2:15, so perhaps before 3:20 we'll complete our class. So today's class is just continuation from previous class. So last week, so I have explained about the concept of transmitter and receiver as part of the what you call revision. Okay, basically we have the four components plus the antenna. So the four components includes the filter, amplifier, oscillator, and mixer, which we will learn in this course. So we have looked on the part of, so this I already gone through very fast. Okay, some explanation of a basic receiver, and also some basic explanation of image frequency. So actually you can refer also some of the notes from the microwave engineering book, whether you can get it hard copy or soft copy. Last week also I have explained about the signal to noise ratio concept. So you can refer to the previous video if you want. So this one I don't touch. Okay. So this is another important part of this course. Okay. So today I want to touch about the dynamic range. What is dynamic range and what's the other things related to dynamic range? So in mixer, for example, mixer, amplifier or receiver system operation is normally in a region where the output power is linearly proportional to the input power. So you have learned about the voltage, the current in maybe in the first year related to the electronic subject. So normally these components are working in the linear region, but some may be operating in the non-linear region. So here at this region, basically we can transform, for example, output over input, you can measure it again. If the output is bigger than the input, so it's considered increase in gain. If output is less than input, so you can consider it a conversion loss. So the definition of dynamic range is basically referring to a graph. So it's defined at the range between the 1 dB compression point and the minimum detectable signal. So basically, so this graph is an important graph where okay, so this is the linear region. So this linear region is a straight one. So where following the graph of input power versus the output versus input. So basically output over input, you can have a gain or loss. If a positive is gain, if a negative is loss. So this is the linear region. This linear region is what we call the dynamic range, which is a definition of a linear power output, which is linearly proportional to the power input. Or in other definition is the range between the, so here we have a PD, what we call the 1 dB compression point, and here at the range is what we call the MDS, minimum detectable signal. So this dynamic range stay between the PD and MDS. So that's the definition. And what is PD? So PD is what we call the 1 dB compression point. You can see the graph, we go straight and then after that it will saturate. So at this point, okay, PD is taken slightly higher additional 1 dB to reach this point, where this 1 dB compression definition is conversion loss increased by 1 dB. So it increased by 1 dB. So this is the definition of 1 dB compression point. At this level, okay, power are not converted into the desired IF, and the power is considered heat, converted into heat. So because it is higher than this is considered non-linear region. So maybe some of the output is not useful. For MDS, minimum detectable signal, so at the lower part here, so is the noise floor. So this noise floor will disturb the operation of the signal, so it's considered not useful. And here at MDS is the minimum detectable signal. So this is the start of the components can be operated. So these are the minimum detectable signal. So there are some calculation value. So I will explain about this. In addition to that, okay, what else? So from this graph also, so basically this is the what you call the fundamental graph of output versus input, where we have the linear and saturation region for the fundamental or first order modes. So beside this, we have the third order, fifth order operation. So if you can go, we can estimate at the higher order. Kenapa dia tak padam? Okay. If we increase it, we have another one what you call the third order modes. So these third order modes are output power of third order or 2-tone intercept point in dBm. So this is a first order, this normal one. So this is the third order. So at one point, this third order will meet at one point at the top. So this is another definition of what we call the IP3, intercept point of third order point. So this I will explain later in the theoretical part. So why we need this? Because we have some calculation which is related to this operation to know the region of operation. So we can calculate some of the operation here. So mana dia punya calculation? Oh, saya sendiri. Okay. Okay, here's some example of calculation. For a mixer amplifier, or receiver system, so that the dynamic range can operate over a wide range of input power level. So basically, if you want to calculate, okay, from the graph, So first we need to know the noise level or the noise floor. So using the formula of what you have familiar before, KTB, which K is the constant value, T is the temperature in Kelvin, and B is the bandwidth. So you can calculate the minus 14, the KTB, and you get directly the unit in dBm. And what is MDS? Based on the graph, MDS is defined as 3 dB above the noise floor, and it is given by this formula. So it is an MDS is the noise floor plus 3 dB. So this is the minimum detectable signal. So if you have the graph just now, so the graph is something like this. So this is MDS. MDS, so which is, this is NI, noise level, which is the difference is 3 dB. Okay, now we move to the 1 dB compression point. So as a definition before, the input level, power level at which the compression loss increased by 1 dB is called the 1 dB compression point. Okay, so beyond this range, the compression loss is higher. So it's used, normally it's useless beyond this point. Okay, so we can calculate the 1 dB compression point. For example, we can calculate the PD here using this formula. So PD is equivalent to P out minus G plus 1. So this is for amplifier. So because it has a gain. For a mixer, so it uses the conversion loss. So mixer will have a loss, amplifier will have a gain. So the power out is plus LC. So this is in order to calculate the 1 dB compression point. So when you know the MDS and you know the PD, okay, you know the MDS, you know the PD, so then you know the DR. What is DR? The dynamic range. So if this is minus 114 dBm, if PD you calculate, you have 0 dBm, so the difference it will be 140 dB about the dynamic range. Okay, so this is how you want to calculate the dynamic range. So this is the easiest way. It's just by using the graph. So normally in my course, so there will be always a basic question related to this. Okay, so you need to know about how to calculate the DR, based on the PD and MDS. Okay, so this just, I think every year in the final exam question, being asked about this dynamic range. Okay, this is what we call the third order intercept point. When the two tone third of intermodulation products are of primary interest, since they tend to have frequency that are within the passband of the first IF stage. So when we have at the receiver, so we receive the RF power, then we we mix with the local oscillator, then we got the IF, intermediate frequency back at the receiver. So at the receiver, when we go to the mixer, we're mixing this. So we have the first order product, third order product, fifth order, seven, and so on. And some of the higher order product will disturb. I can say this the word disturb because the frequency falls nearby the primary interest. So for example here, okay. So if we have the two RF signal, F1 and F2, and we hope we can get only the first intermediate frequency and second intermediate frequency. Unfortunately, the image frequency also occur, which is this part we actually don't want. So this is the information that we want, which is carried in the IF. When the addition of the third order, so for example here, the first image and the second image appear here. At the end, okay, so when we do mixing, okay, so this is the RF power with high amplitude. So this actually we don't want. We want it's just used to for the transmission. The things that we want is only the intermediate frequency, which is only this part. But unfortunately, the image occur at the side. For example, this may be the due to the third order. It falls near to the required or wanted frequency. Okay, we only want this frequency, but unfortunately, the image frequency appear just nearby. With the amplitude also, normally it's quite high compared to the signal that we want. So here actually it's difficult to filter out. So this is the challenge on the radio frequency designer. So we want to design things for the to allow signal that only we want. So when you design, for example, mixer, so you need to consider these things. Okay, so this some the definition here. So actually, when you attend my class also, you can already maybe print out or open back or review back all the slides. So I usually operate because they are large magnitude and because these are difficult to filter out. So this F1, F2, we don't care. So we only care about high intercept point indicate high suppression of undesired intermodulation product. So this is just a definition of the IP3 that I have explained before. So this IP3, which is the fundamental and third order, which I explained before. So this is the linear region, then it saturates, but it's attracted that if we continue the concept of linearity, it can reach to a point where we call the IP3. Never mind, this is just a basic theoretical concept. Okay, so from the slides, again, so modulate showing all the 4 components. So whether it's transmitter or receiver, we include all these components. So previously we have seen the receiver and receiver consideration. So this time you see about the transmitter consideration. So the power output, the operating frequency. So normally these are the important parameters in order for transmitting process to be done. Okay. So I think another part of important part to analyze the transmitter and the receiver components, we use the S parameter. Again, you have learned it during the last semester subject course under Dr. Rijal. May I know everybody attend? I think everybody should already attend the microwave engineering course. So that I think because it's compulsory in order for you to take this course. So I believe everybody have learned about the S parameter. Okay. So again, as a revision, so you can analyze electronic components, amplifier, filter, oscillator, mixer in the lower frequency. How do you analyze that? Normally you analyze that depends on the voltage and current. So you have learned it during the first year or second year in electronics. You have analyzed that voltage and current. But when you go to microwave engineering, it is difficult to analyze it. So one way, researcher, they try to find a way to analyze the system. So one way is to analyze using the S parameter. And what equipment that used to measure the S parameter? The equipment used is what we call the network analyzer. So besides using so equipment used to analyze the S parameter is called the network analyzer. Kenapa? Okay. So this is the equipment used. So if you are here, maybe you can come in 2000. Perhaps COVID will gone. So I can bring you to WCC, Wireless Communication Center, and to see all the equipment. So the equipment is not cheap in order to analyze the S parameter. But you able to use the Smith chart, online Smith chart or whatever, even from your home. The network analyzer equipment is just to analyze the prototype. So besides S parameter, you have many other way to analyze the network. You can use ABCD, Z parameter, Y parameter. Okay, so these are the parameters that can be used to analyze the network. So this the limitation of current and voltage analysis. Okay, why we don't use the voltage and current? Because open short termination hard to produce in RF microwave band, can cause oscillation. So this one you can read. So we use what we call the nodal current and voltage concept based on nodes. Hard to measure in RF microwave circuit, hard to define in waveguide circuit. So we use the S parameter, especially to do the matching. So this is the two-port You can analyze the S parameter using the 2-port network, 3-port network, and so on. So you have learned this also. Okay, so dah habis pun slide. Mana nak tutup ni? Keep. Okay. So ada soalan? Any question related to this? Belum habis pun lagi. Oh, okay. Saya ingat dah habis. Okay. So normally to analyze the S parameter, okay, we use what we call the Smith chart. So I hope you are already familiar with this. So why you want to use the Smith chart? We want to mesh the circuit. So in the Smith chart, the middle part of the Smith chart is where the matching is done. So basically in this design, we will design amplifier and oscillator design for matching. Filter also we will use it for matching. Okay. And normally what we use in the Smith chart is in the normalized form. So what is normalized form? So normally we will normalize it to the load. Okay, that's why we divide to that's why we divide with the impedance. Okay, normalize to Z0. We normalize load ZL, and we got the normalized load. It's just a revision. Okay. So we want to bring everything, we want to bring the matching into the center of the Smith chart. So if it's not matched, let's say it is here, so we want to bring it near to the what we call the unit circle. Okay, so this is the basic concept. Then from the unit circle, we want to bring it to the center. Okay, so just a revision here. So we have the Z load. Okay, we have some impedance here. 50 ohm, let's say. So this is the L plus something. So we want to add this red box. Okay, maybe maybe inductor and capacitor, or something to represent impedance in order to match ZL and Z0. So that's the purpose of matching. So I have given the assignment, so basic assignment, using 3 ways of matching using the what we call inductor and capacitor matching, circuit matching, using the stub matching, and using the quarter wave transformer. So all these are 3 types of matching that you need to use the Smith chart. Okay, besides that, you have the Z chart, Y chart, ZY chart. Okay, so this is the Smith chart. The reason for matching, okay, so we want the maximum power is delivered when the load is meshed and the power loss in the feed line is minimized. So basically, if you draw so there is Z0, this is something, so this is ZL. So you want to add this ZZ, so that the power delivered from the source can be delivered to the load nearly 100%. So we cannot get 100%, maybe at least 90%, 95% power delivered is already very good. So we want to introduce this ZZ as the matching element. So when we able to increase the maximum power delivered, so we can improve the signal to noise ratio, and we reduce the amplitude and phase errors. So these are very important of matching. So this is the first technique of matching using the lump element, where you have whether to use the what we call the parallel first, then series, or series first, or then parallel. So there are two questions in the assignment. Okay, you can use single stub matching and quarter wave transformer. So you need to show your assignment. Okay, you need to maybe to draw this so that you can know the quarter wave and what is additional length that maybe you need to use in order for matching to be done. So you already know, for example, this is the length of quarter wave length, and maybe some additional length you need to add before the quarter wave length. So you need to look how to design it. Okay. So dah habis kelas Kita tengok, saya nak tengok sekejap. I want to see other slide. So this is the slide what we call the I call it is 1A. So I give you the slide from 1A until 1E. Yeah. So basically 1A until 1E is just a revision. There are also some example. So 1B is principle of complication. Okay, kita buka lah satu-satu. Okay, so this is just a basic. So I don't want, you can refer actually. So I don't touch much because this is just additional information for you to revise. 1C about the concept of scattering parameters, again for you to revise. Okay, especially on the two-port networks, what is called the S11, S21, S12, S22. So input reflection, forward transmission, reward transmission. But don't worry, in the test, I won't ask again about how to calculate, for example, how to calculate S11, how to calculate S12, S21, and S22. So you don't need to worry about that. So here, you just need to know maybe some basic. What is S11, what is 12, 121, and 22. Don't need concern about how to calculate. I won't ask again because I think the student have difficulty in order to calculate the S11 value, S21, for example, in this circuit. So apa ada lagi? A, B, C. Boleh open lagi ya? On this next chart. Okay. Boleh buka tak? Tulasi us, Dr. Single section mean equivalent to lambda over 4. That one is for quarter wave transformer. So it's called the lambda over 4. Lambda is wavelength. If divided by 4, is a quarter. So this is the lambda over 4. 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 So this is the lambda over Yes, it use single section because in designing filter, for example, you have multiple section of transformer. Tak boleh buka ah. Methods. Why? Okay, if not, I will change to. Tak boleh buka sini. Okay, stop broadcast here. I change to this computer now. Doktor, tak dapat dengar doktor.
Doktor lupa buka mic ni. Hello doktor. Doktor dengar saya tak? Hello doktor.
Saya nak gelak ah.
Okey, baru dengar saya, baru dengar.
Penat
Ya,
saya
boleh
cakap
dengar.
seorang-seorang tadi lah. Gambar pun tak ada. Okey,
Korang doktor tak dengar tadi
nampak video je lah tadi.
Nampak suara kita orang doktor tak dengar tadi eh?
Memanglah saya pergi tutup, saya tak buka speaker. Tak perasan. Okay. So I don't want to repeat back. Okay, like this. So basically just what I explained, basically you need to use the 3 techniques for matching. Okay. So you have the lump element matching, you have the stub matching, you have the quarter wave transformer, which all being asked for the first assignment. Okay. And all the slides that I put or I just explained just now, it's just the resource for you to refer. And also you can refer back the microwave engineering book. So why this is important? It is because of in designing the filter, designing the amplifier, mixer, oscillator, so everything need matching. So you can use all these 3 types of matching in order to match your circuit. So why matching is important? You want to have for example, nearly to 100% power being transmitted to the load. So basically this is the key point of designing the matching circuit. So you won't get 100%, but maybe you get 95% or 90%. So maybe some circuits already very good. So when you design the matching network, okay, so for example, designing the stub, you can have the double stub, triple stub, but so when you increase the number of stub, for example, or you increase the number of quarter wave transformer, you can improve the matching. You will increase maybe 90%, increase to 95%, increase to 98%, you can increase. However, you will increase also the complexity. So when you increase the complexity of the design, you will increase the cost of designing the matching network. So if the size is big, for example, it's only suit for the handphone, so maybe you need to have a very small matching circuit, which is maybe the matching is 90%. 90% maybe is considered already good. Okay, so today, so basically, throughout about 10 minutes just now, when I just speaking alone, so I explaining about these 3 circuit, 3 matching technique. Okay. Sorry for my mistake. I think because I used 2 devices, I off 1 device and forgot to on the laptop device. So anyway, you have been given the task to design a matching circuit. So the due date is on Wednesday. So please submit it. Then I will maybe share it in the link, the Google site. And I'm thinking about maybe give some prize for the best video. Manalah tahu kan, tiba-tiba tergerak hati saya nak bagi something ke. Okay, so do the best. And also there are marks that I will consider for this first assignment. Just do the best. And so next Thursday we don't have class. Tahu tak? Cuti.
Sir?
Yes.
Sorry to disturb. Yang tadi yang Sir explain for the class today.
Yeah.
Yang tu slide chapter 1 berapa yang Sir? 1E
Boleh buka je lah. Hampir semua tu.
Oh, dia continuous
CDE tu lebih kurang sama je. Itu all are the resource for you to refer. So basically all of it referring to the 3 techniques of matching. So it's just a resource for you to refer.
Oh, okay. Thank you, Doctor.
So basically, so consider, I think I've done for the introduction part. Cepat sangat, laju sangat. Apalah, basically this introduction part you have learned during the last semester. So I just want, the important part is the matching. So if you don't know how to do the matching, your circuit won't work. And this question being asked repeated so many times for this subject also, for matching. Even the final assignment is to design a circuit, okay, using the CAD, computer aided CAD apa device, komputer lah, apa-apalah untuk design. So you need to design the matching. Okay. So this Thursday holiday, so tak ada kelas lah ya. So your assignment will be your the replacement of the class lah. And our next class is next week. So I will maybe play back some of the videos are being submitted in order to recall back the matching technique. So ada apa-apa soalan tak sebelum kita habis kelas? Kejap je, kelas 2 jam, sejam je.
Tak ada, Doktor.
Tak ada, Doktor.
Macam sedih lah. Tak nak habis kelas ke? So saya sebenarnya teringat video yang ada lecturer buat kelas tu, 1 jam kelas dia cakap sorang-sorang. Rupanya dia terlupa buka speaker apa? Terlupa buka speaker, terlupa buka ni lah macam saya, mikrofon. Macam saya agak tadi. Dekat 10 minit agak ya, saya cerita sorang-sorang. Okay, so new experience lah kat saya. Okay, any other question? So anyway, I hope everybody already in the WhatsApp group. You can also already access the e-learning, but maybe after this, most of the time we refer when my Google site to the improve. Okay, so saya senang aja. I will just use this site for you to refer. Everything will be here. So our next video also I will put it here. So when using the Google punya network ni, so everything is in one. So I can use the Google Meet, Google Calendar, Google apa lagi ni? So for example, so I can Google Meet, Google Calendar, Google website, so everything in one. So form also, so semua dah isi kan? Okay. So also using the Google form. So I think it's easier right now. I have learned about to use the Google. So so as a student also you need to know how to use all the available resources. So this is free. So kalau dulu saya malas nak guna ni, tapi nampaknya macam menarik ya. So I will use this. So here, for example, I just copy everything and put it in the Google Meet for you to allow you to enter. So this is the SKET course. So don't worry, I think I will familiar with the website, Google site. Cuma saya tak tahu lah macam mana nak tukar ni. Nama dia tak best. Site google.com.utm.my RF Market Circuit Design. So kalau boleh tukar nama ni lagi best. Okay, I'm process for learning it. Mana ni? Okay, so tak ada question. Kalau tak ada apa, we'll meet next week, but please submit the video video link in the in the Google Form. Saya rasa saya letak Google Form. So on before Wednesday 12 PM. Okay, so good luck. So jumpa lagi. Assalamualaikum warahmatullahi taala wabarakatuh and thank you.